welcome back again. So we are looking at data types and variables, and in continuation with our machine learning training, we just looking at the basics of machine learning first. Then we can now dive into other complex parts, because this particular basics is very important for beginners who do not have any idea of Python basics. All right, last time we looked at some data types we have in Python, and we are looking at another section now called mapping type. The mapping types is we have what is called dictionary in mapping type called dict. So this is a unordered collection of key values, key value pairs enclosed in curly braces. Please just see this dictionary type as what I call it database table. Yes, database table. You just look at that in form of a rows and column structure, because it is called mapping. So you know what that means, that a name mapped to is the map. This name this is the value. All right, Alice mapped to this name, age, the 55 mapped to the age, and New York mapped to the city. So it's mapping 1 to 1. All right. So if you look at this one too, so you have 1 here mapped to this one, 2 here mapped to this one. So it is mapping. So look at this one as a row or just a column. Now the value of the column, another column, the value, column, the value. So it's like a database table. All right, that is how you look at. So in fact, it's used most times to create a data set. Sometimes data set. So you store the data inside it, then you use them later. That's why it's called dictionary. You store the data inside in form of table, rows and columns, and you now use it later. So I'm going to apply that later as we continue, doing as a part of example of what we are talking about. All right, so you can print the type also as usual. If you print the type now, it will give you the type of data, which is called dict. Okay, a dictionary. Then you can also print the name. It will give us the name of the value we print out, which is called Alice. So this means that the value is stored into the name. This 25 is stored into this age. This New York is stored into city. That's what I meant by mapping. So it's stored into it. So when you call this one, what you come out is what is Alice. When you call age, what you come out is 25. So that's I call it. That's why I say it is what is the database table. All right. So this one looks like a variable now. You want to look at the value of the variable. That's what it looks like. All right. That's why it's called dictionary. Now the same thing with age here. Okay. You can see here is mutable. Okay, you can what that means that you can change the value on the go. Okay, it's mutable. You can mutate this age to 25, from 25 to 26. All right, you can print age. If you print out, it will give you the new set of age now, which is 26 now in the dictionary table. Now you can print keys. Okay, which means the only keys we have here is this and this. For this one we have this and this. Two key. So we have key, we have values, key and values, key and value, key and value. So you can print the value also out one by one, and you can say, okay, print city in dict. Okay, in dictionary, in this scenario, print only city. So it will be true because it exists. It's a member of dictionary. So you are trying to check if this city is a member of this dict. That's what you're trying to check. So that is just that version. It's very simple and very easy to work with. So you're going to see a more complex about it later, because it's only used to store. You can use to store a complex data, yes, and work with them later. So now we have what they call set types. Set type we call this one set, right? Because it just see set as a normal elementary mathematics called set theory. Some of you know what they call set theory before in mathematics, where you have a union, intersection, and so on, and Venn diagram and so on. It's like the same. Just understand it like that. You get it correct. Okay. Yes, that is just the truth. Okay. It's a collection of a unique element enclosed in a curly braces. Okay. Let's say we call the variable st now. See 1, 2, 3, 3, 4. When you finally declare the set, it will remove this particular 3, 1, because you have duplicate of 3. It doesn't allow duplicate. That's happened in set also. That's why you have what they call Venn diagram. What's the purpose of that? So that to eliminate duplicate values. So if any value is duplicated in Venn diagram, what will happen to it? You have to put it inside intersection, which means it belongs to both of them. That's what it means. It belongs to this and this. So that's exactly what he's talking about here. So duplicate are automatically removed because it's like a normal set. All right, you can have set 5, 6, 7 can be created from a list, which means it can look like a normal list set. Okay, so if you print the type out, it give us set. Okay, because it's a set type. Okay, if you print the set out, it give us 1, 2, 3, 4, which means the 1, 3 has been taken away because a duplicate value, it won't show that 3. All right. Then st5 hard means it can be mutated, which means you can add elements. All right, you can add element on the go. All right, add 5. So 5 can be added at the end of it. All right, so if you print, you have new set now. Then you can also have what they call union set sd.union. And I was saying the other time that you see it as a mathematical set theory. So you can have union, you can have an intersection, and so on. So you can union this union and this set and C set. You have to want to find the union. I should say all of the set here are here, eliminating the repeated values. So you have 1, 2, 3, 4, 5. You bring them together, excluding the repeated values. Now the union of set st and set st2. So this is a mathematics union set normally, and if you can intersection means that what's common here and here, right? Because we have added 1, 5 to this place now, this one. So what's common in this and this is 5. So that's the intersection. So that's why you can draw a Venn diagram for it, and you can have your correct answer similarly. All right. So we also have what they call frozen set. The frozen set is different from the normal set, which means the frozen set is not mutable. Okay, cannot be mutated, which means that it cannot pass in value on the go. It's frozen. It means it is a freeze type of set. All right, it belongs to class frozen set actually. So if you print a frozen here, it will give you normal set out, which is correct because it's also does not give duplicate. It's also a set actually, but it's a frozen type. But you cannot add 5 to it. For example, here we had 5. Cannot do that here. All right, because it's mutated. So it does not give room to those kind of things. Even though you can see intersect it actually, yes. You can also union it, yes, but you cannot mutate it. All right, so that's the difference between the two. Okay, we have what they call another type of data type called non-type. Non-type means absence of a value, no value inside. That's what it means. So we can have n equals to none. It means nothing inside. It's non-type. So you can print type n, it will give you non-type. So print n is none. That's what you print for you. So we also have what they call type conversion, which means you want to convert a type from one type to another type. All right. So there are functions provided by Python by which you can convert types. So for example, int to float, we have s equals to 10. All right, which is an integer now. Now, if you print float, now we are trying to adding float here means that you want to convert this particular integer value x into float type, which is decimal value, to give you 10.0. All right, so which means now it becomes decimal, or float to integer. It automatically the decimal will be truncated. It will not help you to approximate it. No, it will make it 4 for you. It will make it 3.3, only 3. It will cut off the decimal value. Okay, so you are trying to print out into y now to only give you this whole number and take away the decimal value. Now, string to integer or float. For example, now this is string because it has columns embracing it. It's a string. This means it's just character type of data. That's what it means. So you can print int s here, which means that you are trying to convert this string to integer. We give you 1, 2, 3. You can also print float s, which means you are converting to what to decimal. All right. Okay. So similarly, you can also do the same thing here for float. Okay, to string, you have number equal to 42, but you are trying to use it for string, which means string to put it to 42 with column around it to show that there is a string. Now you can also convert a list to a tuple or set. Don't forget, tuple is also a type of list that does not allow mutation. Don't forget that we did with that last time. All right, in previous class. So we can have a variable called first, which have let's call it is a list actually. We have 1, 2, 2, 3. All right. You can now convert it to a tuple, for example. Print tuple. So for this one, it will give you normally as this. Okay, because it's not a set, it's a tuple now. Okay, so it will give you out complete like this. But if you now convert to a set now, it will remove the duplicate automatically. Why? Because it's now becoming a set. Now set does not allow duplicate. Set remove duplicate automatically. Don't forget that. So similarly, dictionary to keys. Dictionary is a mapping type. Don't forget that it's a mapping type. So which means A, this one map to A, 2 map to B. So if you print D out, okay, as a list, it won't print the value for you. It will print only this A and B, which is the keys out. It won't print the value, only print the key. The key is A and B. So that's what will print for you. So A and B. So if you run this, for example, now if I run this, what I can see, okay, like what it gives me say, okay. So that's what I've been talking about since. So that's just a value. So let's just apply what you have learned so far now, and see how we can use it in a normal scenario. Let's look at a simple payroll system. Okay, this is a complete payroll script that calculates an employee salary using different Python data types that you have learned so far. So the key types we demonstrated here is the string, which is employee name. Let's assume that the name is John Doe, and we have integer employee ID 1001, hours work 40. Then we have float, which is decimal values, hourly rate 25.50, tax rate 0.20. Then we have boolean, which is what status, manager status, either false or true. If you're a manager, true, not false. We have list, deductions that we have this, and this, and so on. So, and we also have implicit type conversion, which means you are converting from one value to another value, such that a float multiplied by integer will give you float. Okay, yes, you are maybe 20 times 3.5 we end up in floating value. Is that correct? So that is correct. So now we also have type rate times conversion convert to float to for percentage 10.5%. So that is the script mimics how actual payroll system actually work. Okay, so we are supposed to store employee data as a test, number as a test, employee data as a number as a test, as a yes or no flag, for example, if it's a true or false. Then we also perform calculations with automatic type handling. We also generate formatted report at the end of the day. So we are going to mix text together with numbers to print out something for the staff. So now let's say employee data using different data type. Now let's declare we assign employee name. Now we say John Doe is string type, employee ID 1001, that is integer, hourly rate is 2250. Okay, float, then hours work integer, is manager is now we are trying to ask question now. That is a boolean now. Is manager false? That is the common value. So is boolean. Now deduction is distortion. We have list here. Okay, list of float. We have tax rate also float. So calculation now. Basic pay is hourly rate work times hour work. That is a float times integer float now. So that is a basic pay. The number of hours you work times the number of the rate per hour. So total deductions is equal to sum of a deduction. Total. So sum to we bring in this particular function called sum to sum together all deduction together. Tax amount, basic pay times tax rate. So that's the tax amount now. Calculate the tax that you're going to pay. You multiply the basic pay now times tax rate. So net pay now becomes basic pay now minus total deduction minus tax. So that is called the net pay. So we have having float operation, which now is float now. So we can now calculate all this now and print our pay slip. So string format with a different type now. Okay. So we are going to use a f string now to print our pay slip out. So which means we want to break this one to multi-line. Don't forget this. Last time I talked about multi-line. Okay. String. So we have a payslip now. We are printing a heading, for example, now using string employee. So we are blending our employees, our variable now. If you are blending variable inside a string, you have to embrace it with curly brackets. Okay, these are variable now. For example, if I want them to be inside my string, I just embrace them with curly brackets so that they can show here. make your work very simple, okay, or easy to handle. So now employee now hide the employee. All right, we are printing the manager. Okay, if it's manager, we are writing if it's manager, then regular employee. If it's manager, which means if it's manager is first, that would be, but don't forget manager is first. Don't forget that is our value for is manager is first. So if it's first, that what it means. If manager is first, then regular employee. Okay, now let us now print out our work now. Our work, you say hours. Our rate, you say this per hour. All right. The basic pay, basic pay times this is what you say 2f means to 2 decimal values. So that is 2f means 2 float points or 2 floating points. Okay, so which means 0.25, 0.33. That's what it means, right? So this one is very important. Don't forget about it, because you may want to use it. If you want to use 3f, okay, 4f is mostly used most time, like for example in a machine learning result metrics, you use 4f when you want to have the full detail, full result. Okay, for example, maybe precision is equal to 0.98875, 0.98887, for example. You can use 4f to print out, because by default it will give you 2f by default. It can give you 9879, but you want to see the all so that you can know how to present them in percentage. If you have 0.9877, for example, that's 98.777. That's what it means. So you cannot cut off 77. It's very important. So that is that. So, but now just have this for now. Deductions, we have insurance. Okay, deductions here. The first one, this is called the first one, the first in the list. Okay, don't forget that this is called index. Okay, we talked about last time. Index means 0. Okay, the first. Okay, we have to convert to 2f. We have retirement deduction. Also, the second in the list, that's 1. Second in the list, in the index, we have 2f. The total deduction now, we have a total deduction equals to this, right? So the tax rate now, we call it tax rate here, then multiply by 100. We want it in this form, okay, 0f. Then tax amount, this one in 2f. The total net pay now is in this form. So if you print payslip now, you should pay to print for us our what they call it, our slip now. So let me just click on run here. So look at our payslip now. Employee John Dew. You can see what we saw here. Regular employee. Why? Because the if I change this one now to if I change here to true, for example, it will change to employee. It will change to manager here. So for regular employee, to be regular employee, to be manager. So you can see manager or regular employee. Why? What control that is this? Okay, so these are just elementary coding for now. So we are going to improve on that later as we go gradually. So hourly work is displayed, hourly rate is displayed, base salary is displayed. All right. Okay. Then we have deductions display, we have retirement display. Okay. We have total deduction display, and we have tax also display 20%. Okay, which we work out here to be 204. All right. So we also have net pay 641. All right, so this is just what we have for now. Okay, I think with that, I think we are okay for now. So don't forget, tax is calculated, tax rate is multiplied by 10 here to give us percentage. Okay, that is how we do it here. So and for now, I think we can stop for now. We continue from there in the next class. So you can go through what you have learned so far under data types to understand the type of data we have so far in the machine in Python, so that when we are applying them later in the time to come, it should not be strange to us. Thank you so much for joining us. If you have any comments, anything you want to share, or want us to talk about that we will meet it, you can just put in the comment box there. I will answer when I have the time. So thanks so much. I really appreciate you for joining.